this video, I'm going to be talking about 3.1 exponential functions. Okay, we have all different types of exponential functions. This is a new unit. Make sure you guys are taking notes on these videos. Stop it, write it down, then let me explain it. Rewind it, let me explain it again. If you still don't understand it, try it again. Try to rewind it, let me explain it. And then whatever questions you have, make sure you're marking them on the side so you come in and ask me those questions specifically. Okay. 3.1 is dealing with exponential functions with your parent graph y equals a to the x. When a is bigger than 1, then your graph is going to go somewhere up to the right. Basically, if it was like y equals 2 to the x, then if you make a little t-chart, if you put in 2, it's going to be 4. If you put in 3, it's going to be 8. Okay, it's going to grow really fast. Just keep getting bigger. The opposite, if a is less than 1, so if it's a fraction, 1/2, 1/3, 1/4, anything less than 1, then it's going to be going down and to the right. So it's going to be getting infinitely smaller. It's never going to touch your zeros. It's never going to touch your x-intercept, so it has no zeros. And therefore, we know we're going to have a horizontal asymptote at y equals 0 for both of your graphs. Okay, let's look at a graphing example. If you have a graphing example like this, you have y equals -2 to the 2x plus 3. Notice this plus 3 is down below, so that means it's actually going to be with the y. For this -2 to the 2x, our parent function is y equals 2 to the x. So the a is bigger than 1, so I know I'm going to do something like that. It's going to be somewhere around that shape. Okay, our parent function is that, so we have this shape with it doing something like that. And I'm going to be doing stuff to this. So again, this is just like your stretching, reflecting move. Remember, I'm Mrs. Backwards. I have a lovely husband at home. He cooks me chicken enchilada casserole almost every night, and I eat it with chips and saffron rice, and it's just wonderful. So if do I have any stringing and stretching? Well, you're not here to answer my question, so I'll answer it for you. I'm multiplying my x by 2. So if I'm multiplying my x by 2, x is opposite, so I'm actually going to multiply my x's. So x's by 1/2. Do the opposite when you're with the x's. Not now, banana nose. Okay, for the reflections, we have a negative on the outside. So if it's not with the x, it means it's on the outside, so it's kind of like it's with the y. So we're going to reflect over the x-axis. And then this plus 3 is our only move, because I don't have plus or minus anything with the x, so I'm going to move up 3. Remember, you got to do it right in order. So first, I'm going to multiply the x's by 1/2. Well, at this point, say we have somewhere in there. If I take the x value here and multiply it by 1/2, it's now going to be up here. So this is going to shrink our graph up quite a bit. Horizontal asymptote is still going to be 0. Then I reflect it over the x-axis. So this point at 1 is now at -1, and it's going to be really steep right there. Horizontal asymptote still at y equals 0. Then I move everything up 3. So this point at -1 is going up 1, 2, 3, and is now there. My horizontal asymptote also has to move. It was at 0, so now if it moves up 1, 2, 3, it is now right there. So I have a horizontal asymptote right here at y equals 4 now. Oops, sorry, y equals 3. And it's going to have the same basic shape after it has been reflected. So the graph in green is our final graph. This is about as hard as you're going to see as graphing goes. Make sure you follow your stretch, reflect, move. Make sure you write it out every time so you realize what you're doing. Remember multiplying? If you're with the x, you're going to do the opposite. If you're with the y, so if you have something like y equals 2 times 3 to the x, this is actually a vertical stretch. So this would multiply the y's by 2. Okay, whatever you're doing, just make sure you follow it. Really important to know your parent graph. Crosses at 1. Okay, that's going to be seen on that 3.1 quiz. You're going to have to do all of this without a calculator. So no calculadora para todo. You're also going to have to do problems like this without a calculator. Okay, we have 2 to the x minus 3 equals 16. What the heck? My x is in the exponent. Can I divide by 2? No. Can I subtract 2? No. So since this x is in the exponent, we're going to have to kind of pull some tricks. Well, 16, well, I know 2 to the first is 2. 2 squared is 4. 2 to the third is 8. And 2 to the fourth is 16. Well, check that out. If I know that 2 to the fourth is 16, then oh my gosh! Then 2 to the x minus 3 must equal 2 to the fourth. Now, since 2 to the something equals 2 to the something else, these exponents must be equal for that whole thing to be true. So then x minus 3 must equal 4. And then you can just solve for x by adding 3 to both sides. So then x equals 7. Don't believe me? Plug it into your original equation. 2 to the 7 minus 3 is 2 to the 4th, which is 16. So yeah, that thing works out. Buonissimo! Okay, looking at another example. Again, you're going to have to do this stuff without a calculator. I have 1 over 25, and I have 125. So I'm going to look at the bases of 5. 5 cubed is 125. 5 squared is 25. 5 to the first is 5. 5 to the 0 is 1. Anything to the 0 power is 1. That's going to come in help later. 5 to the negative 1. Well, if you follow this pattern down, 125 divided by 5 is 25. Divided by 5 again is 5. Divided by 5 again is 1. So if we divide 1 by 5, then that's going to be 1/5. So that means that 5 to the negative 2, if I divide 1/5 by 5, that's 1 over 25. So now I have kind of both the things that I'm going to use. I can write them both as a base of 5. So that I have 5 to the negative 2 equals 5 to the third. 5 to the negative 2x plus 1, sorry. So then since my bases are the same, since these two numbers are the same, I can just take the exponents and set those equal to each other. So that I have negative 2 times x plus 1 equals 3. And then distribute your negative 2 to both terms so that you have negative 2x minus 2 equals 3. Add 2, so negative 2x equals 5. And x will be negative 5 over 2. Okay, follow it step by step by step. Figure out what your bases are, then take your exponents and set them equal to each other. That's all I'm going to talk about with 3-1 in this video. If you want to know about interest, compound, and continuous, I'm going to make another video pretty soon, hopefully shortly, although that won't matter to my next semesters and semesters beyond. And when I'm an old man and 80 and you're still watching my videos and hearing me talk about bananas and just like, what the heck, Mr. Pike was crazy when he was younger. Yeah. Good luck, old Pike, with those running rapskillions.